Hello students, today's agenda is we're going to be graphing with the intercepts, and you guys are going to be ready to do assignment 11.2. Today students will be able to find the x-intercepts and the y-intercept of a quadratic equation to then sketch a graph. Okay, the first one that we're going to look at is y equals x squared plus 2x minus 3. And before we even go into that, I'm going to show you an example to show the linear equations so that you can, I guess, recall. If we have, this is a linear equation because it has no square for the x, so it's 2x plus 4y equals 8. And for the x-intercept, remember that y equals 0. For the y-intercept, x is equals to 0. And so basically, before we only had that, we used to call it the crossed eyes or los viscos in Spanish. So basically, the opposite is equals to 0. And if you get the equation and replace the y by 0, you get 2x plus 4 times 0 equals 8. 4 times 0 is 0. And so 2x plus 0 is 2x. You keep bringing down the 8. And then divide the 8 by 2, both sides by 2. And so x is equals to 4. So that's how you get the x-intercept, which is this point right here. For the y-intercept, x is 0. So you will replace in the original formula or equation the x with 0. And so 2 times 0 is 0. Bring down the 4y and the 8. 0 plus 4y equals 4y. Divide both sides by 4. And so we cancel and get 8 divided by 4 is 2. So that's your 2 right there. So this is graphing linear equations with the intercepts. Just to remember that the opposite is equals to 0. And so how does that apply in here? That if we're looking for the y-intercept, we're going to start with the y-intercept. X will be equals to 0. Okay, so we're going to replace x in both of these ones. So it's going to be y equals 0 squared plus 2 times 0 minus 3. And so 0 squared is 0, plus 2 times 0 is 0, minus 3. So 0 plus 0 is 0, minus 3 is negative 3. So my y-intercept will be x is 0, y is negative 3. Something that I want you to notice is that for my y-intercept, the value of y is that last constant number. Okay, so that's something I want you to look at, to have in mind. Now, in previous lessons, I've been telling you how to get the x-intercepts. And the x-intercepts, we're going to have usually 2, sometimes 1, and sometimes we won't have any intercepts. But for the x-intercepts, y is equals to 0. So this y we're going to replace with 0. And from here on, you can either factor to solve for x. You can use the diamond method or just the perfect square. You can complete the square, or you can take the square root. I mean the quadratic equation. Okay, for now, we're just gonna see both of these factors. These two numbers can be factored so that when you add them equals to positive 2. So are there two factors that multiply equals negative 3, but when you add them equals positive 2? Well, we have 1 times 3. Since this is positive, I'm going to leave the bigger number positive. And negative 1 times 3 is negative 3. -1 plus 3 is equals to 2, so those will be correct. So I'm going to solve this one by factoring. And so I'm going to put xx and then -1 plus 3. And so what value of x would make this 0 so that when I multiply that 0 times something else equals 0? Okay, one of my two factors have to be equals to 0 to have an answer of 0. So the value for x needs to be equals to +1, so that +1 minus 1 is 0, or -3, so that -3 plus 3 is equals to 0. Okay, so those are my values here. So I already have my y-intercept and my x-intercept. Now, we're going to do a sketch for that. And so let me move these to the side so that I can do the sketch in here. And again, this is a sketch because we don't have all the information. Yesterday's lesson, we shared that we would find the vertex, the lowest or the highest point in the parabola, but today we only found the y-intercept and the x-intercepts. So the x-intercepts are going to be at 1, 0, so right here, -3, 0, so right here, and my y-intercept is going to be at 0, -3, so right here. And we're going to do a sketch. This, if we look at symmetry, it's probably going to be around here. But we don't know this point. We don't know the vertex. We'll figure it out where we, like, I don't know if it's going to be a little higher or a little lower, but we're going to learn that in tomorrow's lesson. Okay? So for now, this is all you're going to give me. The x-intercepts, the y-intercept, and note that more or less that's how it would look. Okay, that's how you would sketch it. Okay, let's do one more example. Okay, how do I find the y-intercept? For the y-intercept, x is equals to 0. So I know that I'm going to replace that by 0. And so 0 squared is just 0. 0 minus 49 is -49. So my my y-intercept will be at 0, -49. Okay, that's my y-intercept. For my x-intercepts, I replace y with 0. And I can do this one in two different ways. It can be with factoring or by canceling. Both will give me the same answer. By canceling, I just add 49 to both sides. And so I'm going to have 49 is equals to x squared. I take the square root of both sides, and so x is equals to plus or minus 7. Okay, so there are my two values right there. So my x-intercepts will be 70 or -70. Okay, and for my sketch, all I need is that it's going to be a +7, at -7, and my y-intercept is going to be a 0, -49. 0, -49. Now, from here, I'm going to open it straight up. How do I know that this is my vertex also? Well, because it's the same distance. Remember that the vertex will be this in the middle of the two intercepts, so that makes it easier for me, right? So I know that this is the point of symmetry, the line of symmetry, so since they're equidistant from the origin, that means that this is my vertex. Okay. I think I want to do this by factoring also so that you can see the difference. I'm going to move it up a little bit. And so the way we do it is that if this is a perfect square, and a minus, very important that we have a minus in the middle, then we know that it's those special ones that you just put xx, 1 plus 1 minus, and the square root of the second one, which is 7. And my value of x is the opposite, right? What will make this 0? A negative 7. Or what would make this 0? A positive 7, because 7 minus 7 is 0. So positive 7. So see, we get the same answers. It doesn't matter if you do factoring or canceling. The bell is about to ring, so don't think class is over. But let me do one more. I hope I can get to it before it rings. I don't know if I will. Okay, if you recall, your y-intercept is just that one last point, the number, the constant number. So I'm just gonna do it as a shortcut, and so the y-intercept in here will be 0, and my constant number is 8. Okay, again, if you want to do the whole work, it's gonna be 0 squared plus 4 times 0, and those disappear basically because it's 0. For the x-intercepts, as promised, for the x-intercepts, y is 0. And so I'm notice that there are not two numbers that multiply equals 8, but added equals 4, because it would be 2 times 6, that will be 8 in here, or 1 times 8 is 9, so it doesn't make sense. So it's going to be y equals to negative b, I'm going to use the quadratic equation, negative b plus minus the square root of b squared minus 4ac all over 2a. And so that's equals to negative 4 plus minus the square root of 16. 4 times 1 times 8 is negative 32 over 2 times 1 is 2. And so that's negative 4 plus minus the square root of negative 16 over 2. And so that's negative 4 plus minus, whenever we have a negative, we have an imaginary number. And the square root of 16 is 4 divided by 2. As soon as I see a negative, I know that I have an imaginary number, and so I'm not going to have intercepts for the x. No x-intercepts. So my graph will not touch. For now, what that means is that the only point that you will have is your y-intercept. And so I'm not sure if my graph will be on this side or if it will be on this side. Okay? For now, I just want you to find that point and just put a question mark with a parabola in here and a parabola in the other side. We only know for sure that this parabola will not cross my x-axis because of that imaginary number. Okay? So I hope this helps. There is one like this, but for the other ones, you can just solve as we did with the previous examples. Okay? And now you can do 11.2.